Hi everyone, my name is Anton Bukov. I'm co-founder of 1inch. I'm here to tell you why DeFi is the future of finance and why it's better future in some aspects. So the main 3 points here is transparency, composability. Oh, I don't see anything. 1 second. Yeah, transparency, composability, and efficiency. In terms of transparency, anything in DeFi, any protocols, the transparency means that you can check and see balance of every account. You could see total balance of the system. You could see any internal accounting things which are happening inside smart contracts, because that's the way how they work. Their internal data is available for analysis. And this means that if any system have some number of users, they have some deposits, you can always check if whole system is solvent and sufficient. This means that if everyone can withdraw their deposits and it's still fine, or they have some gap in liquidity, yeah, you can analyze this. One more point is equality of access of participants. So everyone, every user, every arbitrage trader, every business have the same access to those smart contract platforms, DeFi platforms. And if someone have advantage in time or price or anything else, it's transparent. You can find this in their code base that someone have some advantage. So equality of access is not like mandatory. It can be non-equal, but it can't be hidden. Next point is DeFi composability. What I understand under this is that every project which is on-chain, it can be used by any other project which can build something off-chain or can build anything on-chain on top of it. So that's how we end up in DeFi having different yield sources, like staking, like lending, like really different opportunities. But we also have yield aggregators. That's systems where users deposit their assets, and these systems, they redistribute their deposits in other systems. And this works thanks to composability. This is how programs can be in touch with other programs, how they can use their APIs on-chain and off-chain. For example, when we launched 1inch aggregator, we discovered that there were like multiple different decentralized exchanges, but each DEX is actually a smart contract, which is like a backend, and a front-end website. And we came up to vision that no one website have exclusive access to their own smart contracts. This means that anyone can build front-end for smart contracts which are deployed by someone else. So actually 1inch was a separate front-end for existing smart contracts, but we also shipped our own smart contract. Yeah, but all of these things is how composability works actually. And permissionless access. So yeah, if you're trying to access backend API of closed systems like Facebook, Twitter, whatever, yeah, they can restrict you. You need API keys. Yeah, it could be complicated, and you could be actually constrained from having like a full access. I'm not sure you can build fully functional Twitter X client without violating their rate limits. But yeah, with smart contracts, blockchain, DeFi, it's possible. Your access to those systems is permissionless. No one can restrict you. But yeah, technically it's possible to restrict only you, but no. Okay, and probably the most important point of DeFi is its efficiency. It's actually coming from few points, because liquidity there is global. So DeFi liquidity is actually global liquidity. It's not associated with any local market. It's not European, it's not American, it's not Asian. It's global. It's truly global liquidity, and the only thing which drives this liquidity is pure risk-reward game theory. So yeah, liquidity is moving among different opportunities, and yeah, it's actually rebalancing risk rewards. So yeah, taking risks into account, analyzing rewards, and making projections based on this. So DeFi is one of the most efficient markets, and how we end up to this, that's because of non-regulation. It was never regulated for like true regulation. And yeah, regulation stacks innovation. Here we don't have regulation, that's why DeFi is so innovative. And yeah, I have small bad news regarding this DeFi thing, and we have some new risks which we should take into account, handle, hedge, whatever you can find. So yeah, there are self-custody risks. Owning your private key is a responsibility. You can lose your private key, or your private key could be stolen by someone. And there are protocol risks. So, 1 second. Yeah, I have a separate slide about this. OK. Yeah, you can lose access, or your key can be stolen, and your funds will be stolen. So there are a few ways to mitigate this, at least multi-sigs and hardware wallets. Multi-sigs is something which can prevent both stealing your funds with stealing your key and losing your funds with losing your key. If you would set up account like a multi-sig 2 of 3, this account will be able to perform actions when at least two owners agree, 2 of 3 owners. This means if any of the owners will lose their key, you will not lose access to this system, to this multi-sig. If one of the keys will be stolen, you will also funds will also not be stolen because you need at least 2 signatures. So yeah, you could have much more complex multi-sig solutions like 4 of 7 or 5 of 7. It depends on what exactly you're working on. And yeah, for sure, hardware wallets. Hardware wallets is a thing which basically idea of hardware wallet is to have private key or seed phrase stored on a separate device to avoid viruses or any other things steal your keys. So if you have separate dedicated device owning your private keys, and you use this device to agree or cancel digital signatures creation, so yeah, you're like owning your keys, and it's much harder to steal your key. Both of these ways help to mitigate those risks. And there are protocol risks. Since all those protocols, they're like, their code is usually it's available. In worst case, if it's not available, bytecode is available, which is harder to read, but is still possible to analyze and find vulnerabilities. So code base could have some bugs. These bugs can lead to hacks. Code base could have backdoors. Backdoors allows owners of this smart contract or deployers of this smart contract to do something, to lock funds, steal funds, whatever. Both situations are not good for users. But yeah, the way how users can mitigate this is actually those 3 factors. This is auditors who can audit code. TVL, here I meant actually total value locked, or number of users and amount of their funds being used in this protocol, and for sure time. So this means that if protocol have audits, if it's working for long period of time and have big number of users and their deposits, it's probably much more safer than other protocol which was deployed yesterday, because it's like more time proven, value proven, and yeah, audits proven. But there is no any other way to guarantee 100% safety for smart contract code to have no bugs. There is no way to do this. For example, we in 1inch we have like a code values. When we develop protocols, we try to make their code base as much compact as possible and have as much audits as possible. This is giving us like a extra feeling of protection. Less code, more audits. is safer than more code and less audits, for sure. Because developers should know that every code have bugs. And for example, Microsoft, one of the biggest software engineering company, they have code standards. And one bug, or like 2-3 bugs per 1,000 lines of code is a good code base. So yeah, we can't have this in DeFi. So you would better develop platforms with hundreds of lines of code and few audits. It would be much better than develop system with tens of thousands of lines of code. Yeah, that's actually a separate topic on how you should develop smart contracts. I should make slides about this. Okay, that's it. Any questions? Yes. Okay, the question was how 1inch is different from any other aggregator. Okay, I think I can answer like that, we actually invented this thing, DEX aggregation, and we are going forward with it. We are inventing next things. We invented Dutch auction-based price discovery. It's called 1inch Fusion. And we invented non-custody cross-chain solution, which is called 1inch Fusion Plus. We're actually heading to all-chain, to be all-chain, cross-chain. And we have the only self-custody solution on the market. This means that in every moment of this cross-chain swap, you own your funds, and you can't stuck in a situation where your funds in someone's hands and they're asking for your documents or whatever they could ask you, or they're stealing your funds and running away. We don't have this situation because our protocol is based on atomic swaps idea, which was proposed in 2013, a while ago. But yeah, we made this concept much more modern with intents and everything else. So yeah, my answer is that we push forward the technologies much. I think we're dedicated to this much more than anyone else, probably. Other questions? No questions. If I still have time, I can tell more about software, smart contracts engineering. And yeah, if it's interesting for you guys. Yeah, okay, I see some signs that you are interested. Okay, I will talk until they will kick me out. So yeah, we came up to vision that code base should be compact as much as possible, but it should be really efficient as much as possible, because efficiency here is actually not about like micro optimizations. It's more about high-level data structures and algorithms and your computational complexity of your code and storage complexity of your code, because blockchains have very limited computational capacity. They are limited in terms of gas or calculations per second, per minute, per hour. They're usually limiting this to prevent their state growth. For example, Ethereum EVMs, they want to have nodes which you can run at home. You can buy a computer for a few $100 and be able to run node. And if state will grow like to hundreds of terabytes, it will not be possible. It will lead to higher centralization. So I think that computational complexity of blockchains, it will be limited almost forever. So we should expect numbers grow, but they will not grow dramatically. They will not grow like millions of times, and we will not have much more computational power per user. So you should use algorithms which use infinite scaling, or like constant complexities, or at least logarithmic complexities when they process data. For example, some systems are already using it, like money markets. If you would check money markets like Aave, Compound, and everyone else, how exactly they work? They work that hundreds, thousands, or millions of users can deposit their liquidity, and hundreds, thousands, or millions of users can borrow liquidity. You deposit one asset and you borrow another asset. What's happening inside this system? they're recomputing your debt every second. Your debt is growing every second, and liquidity of those who gave you these tokens in your debt, it is also growing every second. If your debt is growing with like 10% yield annually, this means that if half of liquidity is borrowed in this pool, that then liquidity providers would get 5% annually. And all these calculations, they're being made in very efficient manner. So it's never enumerating its users. This system is built with the smart formulas that your debt is tokenized, actually. And your price of your debt is growing every second. Your collateral is also tokenized, and price of your collateral is growing every second, but with different speed. And the thing is that hundreds, thousands, and millions of users can use this system, and you actually have like 4 methods: deposit, withdrawal, borrow, repay. And every of these methods have same computational complexity. Doesn't matter how many users are there, how many liquidity are there. So in terms of code base, these methods do not have any loops. So it's just same amount of computation for any action, and it doesn't matter how many users are inside this system. So I have separate presentation about this, about different algorithms used in DeFi. It's called DeFi value flows. It's about redistributing different values in different directions among almost like infinite amount of users, potentially, with a limited computational capacity. And I found a lot of algorithms already implemented, and they are used inside existing DeFi projects. So whenever you are building new projects, you should take this thing seriously. And now that's it. Okay.